All right, so Unit 4 is usually what I call our proofs boot camp. And the reason I call it this is because my kind of philosophy about math is that it should be more kind of inquiry-based and discussion-based, and I hate problems that are just drill and kill, right? Here, do problems 1 through 30 evens or something like that. That's not the way I work. That's not the way I teach. But for proofs, the only way you get good at proofs is if you do them and if you practice them. And unfortunately, this is going to be drill and kill. You're going to have to keep doing it, keep working on it in order to get good at it. And unfortunately, doing this online in videos is going to be almost the hardest way to teach this and to learn it. Because of that, we are tailoring them down just a little bit. We're not getting super crazy with the proofs that we do. But you are going to have to be able to kind of understand, be able to use, and be able to do a proof on your own. So we've already done a couple proofs, but I want to go over this kind of like first page on this packet, as well as get into some of these pages that are in here. Also, because it is distance and we're limited on time, I'm not going to be doing all the problems in here, but I will post answer keys for all or most of them so you can do them on your own if you'd like for practice. So to start here, I want to talk about the different reasons for our proofs. Most of any reason on our proof is going to be found on this page. Now, we've talked about most of these, right? So we just talked in the very last lesson about side, 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 angle, angle, side, angle, angle, side, and RHL, also known as HL, which you might see it, but I always call it RHL. Those are all our new congruency theorems for triangles, okay? But we've done a lot of these other ones too, right? So we have done segment addition and angle addition postulate. We've done all of these properties, right? Reflexive properties, addition, subtraction, multiplication, division, transitive properties, as well as symmetric. We've done all of these definitions as well. So we've done definitions of congruence. We've done definition of midpoint, bisector, perpendicular lines, supplementary angles, straight line. We've talked about all of that so far. So a lot of the stuff that we've been doing in geometry is really building up to these proofs and ready to apply all of that information. We've done most of the ones on the bottom here too, although some of them might seem a little different, right? Alternate interior angles, we've done all of these. We've done third angle theorem. We just did that with you guys in Unit 4. We've done linear pair theorem. We've done triangle sum theorem. We've done vertical angles theorem. And I guess we haven't talked about right angles theorem, but that is just going to be all right angles are congruent, right? So if you see something that's 90 degrees, then you know it's a right angle, and we know they're all congruent, because if they have equal measure, then they have congruency, and that's our definition of congruent right there. So having the exact same size and shape, and thereby having the exact same measures. So we've talked about all of this. Pythagoras and converse isn't actually going to come up in this unit. It comes up in Unit 5. And then these will come up, actually all of these will come up later in Unit 4. So we'll talk about all that. But just note that this whole page has been covered, but I wanted to give you one sheet with everything there so that you can go kind of buy it. Now this by far won't be all of the reasons, but it'll be a good place to go to get you started. So let's get into some of these proofs. So I've got some pictures here of proofs, and I want you to tell me if they are congruent or not. So try, and if you can, tell me which one of the 5 congruence theorems will prove. So is it going to be SSS? Is it going to be ASA, or what it's going to be? So as we start, let me zoom in here. We'll just look at this row. And I want to look at these triangles. So I'm going to start with this first one. And I'm going to say that this one is congruent by side, angle, side. And in order to be side, angle, side, and once again, please, please, please mark up your page on these, is you have to have one pair of sides congruent. Okay, we've got that. Check. Those are congruent because of the tick marks. We then need to have one pair of angles congruent. Check, I've got that, but I don't see that second side that's congruent. So this is going to be where the reflexive property is going to play a huge role here. Okay, I know that GI, segment GI, is congruent to segment GI, and that's the reflexive property. And I know it seemed odd why we did the reflexive property, and it's like, of course, GI is congruent to itself. That makes sense. But the reason it's going to be so important is going to be for these proofs that we can actually prove that they're congruent. So we know that GI is congruent to itself. So side, angle, side. Once again, notice we have a side, then we have an angle, and then we have a side. All right, so let's just keep going here with a couple ones that look maybe a little bit different. This next one here, we're going to have be side, side, side. So I have a pair of sides that are congruent. Okay, so that's the first thing I know. The second thing I know is that we have a second pair of sides, right? They have the tick marks as well. And then once again, we might get a little bit stuck, but if we remember that reflexive property, then I know that this side is congruent to itself. So we have side, side, side on this problem. Once again, we don't know anything about the angles, so we can't start saying anything about them because we don't know. All right, problem number 3 here is going to be an angle, side, angle. Because we have this first angle that's congruent for us. So angle B is congruent to angle E. We then have this next side that's congruent. Okay, we know BC is congruent to CE. And then once again, you might be thinking of, well, that's all we know, right? There's nothing reflexive here, so it can't be reflexive. But there's another invisible one that we know all the time, and that's vertical angle theorem. Okay. Remember, we know vertical angles are congruent, so I know that angle BCA is going to be congruent to angle ECD. So then we do have an angle, a side, and then an angle. And notice here that it's angle, side, angle, not angle, angle, side, because the side is in between the two angles. So that's super important. The side is in between them. It's touching both of the angles, so the S touches both of the A's. Those are the two biggest things that you're going to have to watch out for as you do this. You're going to have to watch out for the reflexive, because that's going to be some invisible information. You're not going to see tick marks about that. And you're also going to have to look out for these vertical angles. So go ahead, see if you can go through the rest of these and figure them out. When you come back, you'll see, actually I'll post the answer key for this, although we will talk about some of them. So when you resume the video, we will talk about some of them and you'll see them there. All right, so here are the answers here. Hopefully you've done a little bit more work in color coding and tracing and trying to figure these out as you go, because that's the only way you're going to be successful with these. So a couple I want to look at. Let's start with number 5. So here, notice we have a pair of angles that are congruent. So angle J and angle L. We then have another pair of angles, angle JMK and angle LKM. And then the last thing we have is our reflexive side here for our first pair of sides congruent. And this is going to be angle, angle, side, because we have an angle, and then another angle, and then a side. Once again, notice the side only touches one of the angles. It doesn't touch the other angle, so therefore the S should only touch one of the A's, not the other A. So this is an example of angle, angle, side, whereas you saw up here in question number 3, we had angle, side, angle, because the side was in between the two. 7 was another little bit of a tough one here, so don't forget about the vertical angles, which are that invisible piece of information, and then that will lead you towards angle, angle, side. Number 8, just note that here it's not a right angle symbol, so we can't say RHL on this one, and we actually don't even know anything about the hypotenuse, so we couldn't use RHL there either. So once again, make sure you don't assume anything. All right, and then the toughest one by far is the not enough info. And anytime you're not given SSS or ASA or something, it's going to be not enough information. They might be congruent. In fact, they really look like they're congruent, but we're not given enough information to figure that out yet. And the reason this one's not enough info is we can take a look at what we do have here. So I have a pair of angles. I then know that I have a reflexive side. And then lastly, we have another side here, which is congruent segment JK is congruent to segment ML. And if we look at what we have here, we have an angle and then a side and then a side. Notice the angle is only touching one of the sides. It is not the angle that's in between the sides. So this is actually set up as ASS. And we all know that there is no ASS in geometry. That's not one of our reasons. That's going to be not enough info anytime you see something set up as ASS. If instead we would have known that this angle was congruent, well, then we would have our side, our angle, and our side with the angle that's in between the two sides. And then we would know it's angle, side, angle. But given the information that we do know, which is that just the blue, the pink, and the green are congruent, that's not enough information. All right, once again, you can find a lot more information on the notes that I posted, the ones that are actually worked out. But I want to just real quick talk about our triangle congruent statements as well. And we'll just look at these last 6, although feel free to do the first 12 of them so that you get good at them. We want to talk about the statement that's going to make the pictures true. So if, for example, I see the order is JKM in this picture, then I know we're going J first, then K, then M, and I have to find the pairing that's going to follow that pattern. So if you want to, real quick, you can see you have 0 angle marks, 1 angle mark, 2 angle marks. So therefore, it's going to follow that pattern of the other triangle, 0, 1, 2 as well. So you want to make sure that you match up all the corresponding parts. So in this case, it's going to be L, M, K for that one. 17, we have triangle RUS. So we have triangle RUS. And notice that we're going over the side we don't know anything about, the reflexive side, and then we have just the one tick mark side. So I got to kind of do that same pattern. Go through the side that I don't know, then go to the reflexive side, and then the side with the one tick mark. So in this case, it's going to be TUS here. Number 16, NOP, is following the pattern of 1, 2, 0. Okay, looking at those tick marks. So I got to go with the pattern NQP, 1, 2, 0. This next one here, FGI. So I'm going from 1 to 2 to 0. So I got to kind of do that pattern 1, 2, 0, HGI. CAB is going to be going from the vertical angles to the 2 across to the 0. So going in that pattern, I'm going to go from the vertical angle through the 2 tick marks and then to the other one. So CDE. And the last one we'll do together, FIG. Here we're going to go F to I, which is going to go across the 2, and then do reflexive. So I need to go across the 2 and then do reflexive, HIG. Once again, for more practice, feel free to go to and look at the notes for those first 12 to see if you can match them up. This is, once again, a really good skill that you need to get good at because this is only going to get more complicated.